Hello, good day today. How are you? I believe you're doing very great. Yeah, it's been 2 months already since you heard my voice, and I've really missed you guys. Yeah, I've missed you in particular. You watching the video. Yeah, exactly. Now, though you cannot see me, but trust me, I'm doing as very fine as well. I must tell you this. I really miss you so much. Now, I'm praying that this pandemic will be over soon and I'm going to see you in good health by God's grace. Okay, yeah, now that you are here, before you undertake your next text on Friday, I have taken my time to put these short videos together in order for you to understand the topic you'll be dealing with. So, look, you're really going to enjoy it. Trust me. The concept we want to learn is very, very, very interesting. It has to do with things you do, you experience every time, every day of your life. So, it's an eye opener to certain things. Now, but let's just go right onto it. Today's topic is going to be on forces. Yes, you can see it's not really a big concept like that. So, in this short video, you should be able to explain the concept of force. You'll be able to identify contact and non-contact force as well. In this video, you are going to be able to set up a balanced force. See, I have packages for you. You are really going to enjoy it. I have videos, I have pictures, and then more to simplify this topic. First, let's start with question for thought. Is it bad to yell? I know your mom or your pap man must have actually told you. Yeah, it's bad to yell. You don't yell at your sister. You don't yell at your brother. Yeah, every time. So, now, is it really bad to yell? Okay, it depends. Maybe you should watch this video first and you tell me whether this man in this video is justified for yelling. So, let's see. I'm actually laughing right now. So, do you think this man is justified to yell? Yeah, you actually know what is happening to him. Nobody is beating this man. And he's just yelling like that. Okay, so, now, is it bad to yell? Okay, in the case of this man, do you think this man is just yelling for nothing? You know something is actually happening to him. He did something, right? Of course, you saw that. So, now, let's go to the topic. Then, before we are through with the topic, maybe midway, you would have understood better. In fact, you'll be able to analyze everything the man did from A to Z that made him to yell. So, still asking the question, is it bad to yell? Let's see from the introduction of force and see what force is actually all about to us in our everyday life. So, in everyday life, the word force means physical strength. Oh, no. Wait a minute. The stronger a person is, then the greater the force that person will exert. Look at this guy in this picture. A very strong guy. Look at his face. Yeah, you actually, by now, you will be imagining that this guy is actually exerting a lot of force on this weight. Now, look at his face. Look at all the muscles. Do you think this guy is yelling? Okay, I don't know. But I'm very sure you know the answer. Let's look at what you do every day that you have to exert force. Do you know you are actually using force when you walk? Yes. When you do 1, 2, 1, 2, 1, 2, 1, 2. On your way to school, 1, 2. On your way to back home, 1, 2. Mommy sent you on an errand, 1, 2. Back home again, 1, 2. Jump up from bed, 1, 2. You are making use of force. What about when you are playing with your friends and tug of war, pulling a long rope? What do you think you both parties, both groups are actually exerting? Force. Of course, you already know that before I actually finished that statement. So, do you know you're actually exerting force when you pull a rubber band? You're nodding your head. Oh, yeah, of course, you are. So, look at this farmer. Actually, two of them. I must tell you, the two of them are actually exerting force. Though something is actually helping them. A pulley. And where is that pulley? You can see that right over there. A rope attached to the pulley. But they have to exert force. This man here needs to exert force to pull the pail of water from the well at the back here, somewhere at the back here. So, and then pour the water into a block container. So, that is a force on its own. Now, let's look at this guy again. This strong man from China pulling up this heavyweight. Oh my God, he must be very strong. You agree with me? Okay, now, what is force? Having known what force is in everyday life. Technically speaking, in science, what is force? A force can be defined as that action which changes the position and shape of a body. So, a force is that thing that will make the position of an object to change, either to move or to stop. Or if it is moving already, to slow down or to change its direction. That thing that makes a body shape to change is also a force. You got me thinking right now. So, when somebody slaps you, is that person exerting a force? You are nodding your head. Yes, is the answer. Now, let's go back to the video. Let's analyze this video shortly. So this man in this video, do you think he's actually exerting a force? Now, before he lifts up the weight, look at him. Before he lifts up the weight, you can see he's actually prepared to do something powerful, something force demanding. He's ready to exert all his energy. He's about to apply force. Because without force, this man will not be able to lift up this weight. Now, watch him. Oh my God. You can see. He lifted up the weight from its resting position right up to his chest. Now, you're about to actually answer that question. If I should ask again, why did this man yell? Oh, because he's applying force. Yes. Of course. Now, let's continue. So, what do you think he's trying to do? Whoa, watch it again. Oh my God. What do you think he was about to bring it down? No, watch it again. God. You can see it. This man keeps changing the position of the weight. Please. First, he moved it from its resting position. Then, look at it now. While the weight is on his chest, he keeps changing his position up, down, up, down, up, down. By simply doing what? Applying force. Wait a minute. Please pay attention to this particular weight. Did you see the ring? I mean the bar that connects these two groups or two sets of rings together, this and this. Now you can see that bar has changed its shape. Before, you agree with me, before that it's not as bent as it is now. So now if no, wait. Don't get carried away with the way he's about to yell. Let's first look at the shape of the bar again. Can you see that he's straight? He has just changed the position again. From being bent to this. And what else do we notice? We also notice that he changed the position of the weight from being up to back to its resting position. What can only do that is force. So, you can now enjoy the yell. Good. Now, let's analyze each effect of force one by one. Force changes the shape of a body. Try this. Pick up a hammer, use it to hit an empty can. I bet you it's going to have 1001 shapes. Yes or yes? That is it. Thank you. So, force changes the shape of a body. That's one of the effects of force. 2. Look at your favorite midfielder, Lampard. Of course, you love Chelsea. Are you in Chelsea Football Club? You like this guy. Now, if you look at this picture, we're going to assume that he's about to take a free kick. Lampard must apply that right force behind. That force must come from behind the ball. And then the force must actually hit the ball at the right position so that the ball can move in the direction of the force. Can you see that now? This ball will not move from its position until it's been hit or kicked by Lampard. So Lampard must apply force to move this ball that is at rest right now up. So that means force makes the body at rest to move. Let's move on to the third effect of force. Again, let's look at Lampard here. What do you think he's trying to do with his leg? Now, we can see that Lampard is actually trying to stop a ball. Yes, being a skillful player, he can actually stop this ball from moving and he will control it right on and it will stop. Of course, we might not be able to see the end of this ball control. So, what does this mean? It means that Lampard is going to apply force again. So, force makes a moving object stop. Let's move on to number 4. Number 4. Force can make a body already in motion to change its direction or its speed. Let's take, for instance, a car that is in motion. Look at this green car here. Now, this green car must actually be maintaining a uniform acceleration or speed. But for it to move on and then change its direction towards this corner, the right hand side, you will see that it needs to apply force. And the driver will actually apply this force in the form of brake. By simply applying the brake, the driver is applying a force on the car. What do you think will happen to the car? 2 things. Number 1, this car, if it's moving very fast before, then it's going to slow down. And then that means force can make a body already in motion to change its speed. 2, when the car slows down somewhere around here, what do you think he's going to do? The driver is simply going to change the position, the direction of the car towards the right hand side. What does that mean? It means force can make a body already in motion to change its speed as well. Now, you have just learned 4 effects of force, but we are going to look at the summary later. Now, back here, let's look at types of force. Of course, there are 2 types of force. We have contact force and non-contact force. So, quickly, contact force is that force that must be seen to touch a body before affecting the body. If you touch your brother or touch whatever that's beside you right now, okay, I'm trying to move it, you have just applied a type of force called contact force. Why? Because your hand is in contact with that thing you want to move. Do you understand now? Thank you. Now, let's look at some examples of contact force. Friction. Do you know friction is a type of contact force? Yes, friction is a type of contact force. Let me give an example of this. Bring your 2 palms together. Try to rub them against each other. You will see that you need to apply force for the 2 ends to rub against each other. There is a force that is trying to stop the 2 palms from moving over each other. That particular force is called friction. Let's look at another example of contact force. Push. Push is another type of contact force. Push. You use it every time when you try to push a box. You just need to move your hand forward and be in touch with that particular box. And you see what will happen to the box. It will simply move. Now, what about pull? By moving something towards yourself, you pull that thing towards. So you are in contact with that thing too. Air drag. Air drag here can simply means air resistance. So air is actually a type of force on its own. This air drag, you can feel it when you are running. You can perceive the sound of the wind around your ear is trying to pull you backward. In other words, trying to drag you. That is a type of contact force. You can see it's in contact with your body. So lift and tension, they are also types of contact force as well. Now we will look at just three of them in picture: pull, push, and tension. Pull is that particular type of contact force that draws a body towards its source. Let's look at this. When you try to pull a box towards yourself, as you can see in this picture, what do you think will happen? You see that the box will move towards your body. Look at it. You attach a rope to the box and your hand is in contact with the rope to pull the box. That is just it. It's moving towards your body. That is pull. Or look at this man. This man is about to shoot an arrow. What do you think he's going to do to the string of arrow for you to shoot it? You see that he's going to pull the string of arrow towards himself. He's applying a contact force as well. Okay, now you have known what pull is. Let's look at push. Push is that kind of force that comes behind the body and moves it forward, opposite to the source. So, for instance, when you are being asked to switch off the light bulb, what do you think they're actually asking you to do? They're simply asking you to push. Push it. You move your hand forward and you see that particular object will move forward too. Now, the same thing when you're trying to push a small ball using a hockey stick. So, that is another type of contact force. So, let's look at the last one, which is tension. Tension is actually a type of force that is being felt by a stretched body. For you to stretch a rubber band, what do you think you have to do? Just simply be in contact. Your hand must be in contact with that rubber band before you can stretch it. So tension is created here. But before you can apply the force, your hand must be in contact with it. Now you understand better. So now let's go on to look at non-contact force. Non-contact force. So non-contact force is the force that affects a body when the body is in an area without physically touching the object. Wait a minute. Let me make it more simplified. Simply put, non-contact force is the opposite of contact force. Recall, contact force must be in touch or in contact with the object before that object can feel the effect of that force. But non-contact force doesn't necessarily have to be in contact with that object. What really needs to happen is that object just needs to be within the area where the force can exact its effect. Now, let me repeat that again. It simply needs to be within a region or space, and then that particular object will feel the effect of that force. Now, let's look at some examples of non-contact force. Wait a minute. Do you know that non-contact force is otherwise called field force? Yes, it's called field force. First, you have heard of the word field. What comes to your mind when you hear field? Football field, right? Good. Now, football field, it simply means an area or a region or a space where football games take place. Do you understand this now? Where football game takes place. So, magnetic force is a field force, or you can call it non-contact force. So, any non-contact force can be called field force. So you can say magnetic force is a field force, or you can say it's a non-contact force. Why? Because the magnet bar does not necessarily have to be in contact with a nail before it attracts it. Do you agree with me? Yes, of course. That nail only needs to be within a particular area, close to the magnet, and you will see the nail will be attracted to that magnet. So, gravitational force is another type of non-contact force. You try to throw something up, you will see that it's going to be pulled downward. There is a force that is doing that, and you cannot see that force. That is a non-contact force too. So it's called gravitational force. Electric force. Electric force is that force that can be felt between two charged bodies. You're going to see that in our next slide, as well as nuclear force too. So let's look at the first three: gravitational, magnetic, and electric force in picture. Look at this lady trying to jump from the top of a roof. Do you think this lady is going to keep floating here forever? Yes. Did I say yes? You know I am wrong, right? Because it's not going to stay floating in the air. There is a force that is going to pull her right down. This force is called gravitational force, as you can see. So we can say gravitational force is that force of attraction between two bodies. Okay, look at this magnet here. This magnet here is not a bar magnet. It is called horseshoe magnet. You can see it looks like this, the shoe of a horse. If you have seen a horse before, it looks curved like this. Okay, so now this bag magnet is simply attracting this metallic ball towards itself, but it doesn't really need to be in contact with it. Now, this particular one has been attracted towards it, and I'm very sure the next one will be attracted to it, and the next one, and the next one, and the next one. This force is called magnetic attraction. So magnetic force rather. So magnetic force is that force of attraction or repulsion between magnetic materials. Now, look at the word magnetic material. Please try to take note of that. Magnetic material. What does it mean to you? It means that some materials are not magnetic. They cannot be attracted. Metallic objects can be attracted by a magnet. Of course, you know that. While non-metallic objects such as wood, nylon, rubber, plastic, they cannot be attracted by a magnet. So, the kind of force of attraction and repulsion between magnetic materials is what we call magnetic force. Now, let's look at electric force. Electric force is that force of attraction between charged bodies. Please look at this picture. Yeah, you need to try this at home. Pick up your comb your hair, and then get pieces of paper. Move your comb towards these pieces of paper, and tell me later what you think will happen. I bet you what you're seeing in this picture is going to take place. And what is it that you're saying? You are seeing the comb attracting those pieces of paper. This force of attraction between two charged bodies is called electric force. The comb you are holding is charged. And how did you know that? How do I know that rather? Because when you comb your hair, you are simply charging up the comb. The comb will acquire certain charges, usually negative charge. When you bring it closer to the pieces of paper, they get attracted to the comb. Now that you have known this, let's now go on and look at forces acting on an object. Let me tell you this. No single force can act alone. We have so many forces around us, both the ones you can see and the ones you apply. So, force always occurs in pairs. What do I mean by pairs? What I mean is that they occur in twos every time. So, when they occur in two, they always act together at the same time, and they act opposite in their direction to each other. So let me give you an example of this. Let's look at this illustration. Do you know that when you pull, something is also pushing? Okay, if you don't know this, you'll get to see in the next, in subsequent slides. And also, do you know when you throw something up, another force is actually acting on that particular object, trying to bring it down. So when you throw something up by lifting it, gravity will pull it down. You can see you lift and that force is acting upward. Yes or yes? Yes. But gravity will bring it down by acting downward on that particular object. So you can see that force always occurs in pairs. Forward and backward, up and down. That is the way it always happens. Now, let's now move on and check, how does a parachute work? Now, I'm actually thinking right now. So, a parachute, for it to work, how does it? You really need to know how it works. Why? Because if you know how a parachute works, then you'll be able to understand how forces act on an object. So, I'm going to be analyzing that in a short video for you. That won't take much of your time. So, look at this. So, we want to learn how a parachute actually works. So, look at this picture. This video clearly. So, imagine that somebody jumped from a plane, and the person has a parachute with him. So, while falling, gravity will be acting on that person, bringing the person down. Since the person actually is not having any parachute right now, so there is air resistance. The air resistance will be acting upward. But let the person shoot up his parachute. As it opens, the air resistance will increase and opens up the parachute. Now, the person is actually floating right now. Why? Because the air resistance is more than the gravity. Oh, and you see that person will gently and slowly land on the ground without being injured. The end. What does that tell you? You have just heard about two different types of force there. Gravity and then air resistance. And remember what I called air resistance the other time? I said air drag is also known as air resistance. Now that you have seen that, one is acting up, which is air resistance or air drag. The other one is acting down, which is gravity. So now you have known this. So there are two types of force pair. We have balanced force and unbalanced force, meaning that the two types of forces that always act together can either balance out or they might not balance out. So, what are balanced forces? So, balanced forces are equal in strength. And then they make a body to remain in equilibrium. Take for instance, when you sit on a chair, two forces are acting on you right now as you're sitting down on the chair. So, one is the thrust, that is the lift of that chair on your body or on your buttock, holding your buttocks in place, is acting upward, while your weight is acting downward on that chair. So, will you move? No. Why? Simply because your weight and the thrust of the chair on your buttocks balance themselves out. So, they are equal in strength and they are making you to remain stable. So, now, what about unbalanced force? Unbalanced force are not equal in strength at all. How do I know that? Because if they are equal, you will not move. Remember, when you are sitting down on a chair. But look at this picture. This man is applying a force on a vehicle. He wants to simply push the vehicle. Now, this push is forward. That is, the force is acting in the forward direction. But there is another force that is acting in the opposite direction, which is called friction. Remember, I told you that two forces always act together every time. So, the applied force of this man on this vehicle, as if you look at this picture, you are going to agree with me that except this man is a jelly, then he won't be able to move this particular vehicle. But if it's not a jelly, he's not a weak person, he will be able to move it. Simply put, this man applies a force on the vehicle and then the vehicle moves. Now, that does not mean that there's no other force acting in the opposite direction. And which force is that? Friction. No. In fact, it simply means that the man's applied force is actually greater than the friction. That is why the vehicle will move. But if it is not greater than the vehicle, if it is not greater than the friction, then the vehicle will not move. So, unbalanced forces are not equal in strength. Is it that one is bigger or smaller? And unbalanced forces are the ones that are responsible for motion. As you can see, the car moving. It means that the applied force is greater than the friction. So, now that you have known this, now let's move on to look at the summary of what we have learned so far. 1. We learned today that a force can be defined as that action which changes the position and shape of a body. 2. We have also learned that force have effects, and these effects are 1. Changes in the shape of a body. 2. Movement of a body from its resting position. 3. When a body stops, when a moving body actually stops. And the 4th one is that a body already in motion changing its direction or speed. So these are the effects of force. And also we also learned that there are 2 types of force: contact and non-contact force. We learned that example of contact force include friction, pull, push, air drag, as well as tension. Non-contact forces include gravitational force, magnetic force, electric force, and even nuclear force. So, last but not the least, you have also learned that force always occurs in pairs. They act together and they act in opposite direction. Forces acting in pairs can either be balanced force or unbalanced force. Balanced force if they are equal. Unbalanced force if they are not equal. This is how we come to the end of today's video. And I believe when you pick up your next test, you will be able to